Respiratory system adaptations. The respiratory system will also adaptations due to consistent long-term anaerobic training, not aerobic training. For example, firstly, internal and external intercostal muscles will become stronger, and this would therefore cause an increase in tidal volume and ventilation, as this would mean the thoracic cavity is pushed out more and therefore allow a greater volume of air to enter the lungs per breath. This is evident in the table above that shows tidal volume and ventilation values before and after training. The table above clearly shows on the left hand side tidal volume and ventilation values before and after these training adaptations have taken place. As you can see, before aerobic adaptations have taken place, tidal volume is at just 500 milliliters. We then see a rise to 1,500, which is a difference of 1 litre. This is a significant difference, and as an adaptation would ensure major improvements for sports performers. Ventilation values also dramatically increase from 7.5 in the before value to 45 in the after value. This also would significantly benefit a sports performer or event performer as an adaptation and would help to lower breathing rate. As well as this, VO2 max would also increase, as mentioned earlier. This is the overall aim of aerobic training, and this increase would allow a performer to reach their full potential. In addition, due to the increase in tidal volume, this would also cause a decrease in breathing rate. As more air is expelled per breath, therefore you would have to breathe less often. This as an adaptation would show a person is fitter and has improved, as they would have a lower breathing rate. As an adaptation, lower breathing rate is an easily measurable way to tell if these adaptations have occurred, as a decrease would show that they have due to the increase in tidal volume that takes place as an adaptation of aerobic exercise to the respiratory system. Moreover, the alveoli will also display adaptations due to this type of exercise, as they will become larger in surface area. This will therefore have the effect of allowing more gas exchange to take place more efficiently. This would mean that the body can be provided with oxygen significant. This means that the blood can be provided with significant amounts of oxygen with less breaths, also causing a decrease in breathing rate. And also, a larger volume of oxygen would enter the body per breath, meaning a person's breathing rate would decrease, as well as meaning exercise could be done more easily and successfully, therefore improving a person in their sport/event. This as well as increased tidal volume would cause the adaptation of smaller oxygen debt. This is because if you can breathe in more oxygen per breath, this will mean that there is more oxygen to the muscles to oxidize lactic acid, and would therefore cause oxygen debt to become smaller. Furthermore, if you can intake/use more oxygen, this will also enable the fast components of EPOC, such as resynthesis of ATP/PC stores and more to occur faster. This is because in order for these fast components of EPOC to occur, the body will need to intake a large amount of oxygen. If you intake more oxygen per breath, this will allow the oxygen needed, which would be between 1 to 4 litres, to be made up faster, and therefore, as a result, this fast EPOC can occur at a faster rate. This overall would mean faster recovery. These adaptations in terms of event or sports performer would cause significant improvements in their game. For example, if a marathon runner could intake more oxygen per breath, this would enable their muscles to be able to work for longer and more easily, meaning their time would dramatically decrease. In terms of football, this would enable a player to be able to run for longer and both recover faster, so they are able to take part in a game quicker in a game or race for a marathon run. Respiratory graph analysis. The graph above shows VO2 during increasing intensity exercise, both before and after these aerobic adaptations have taken place. Firstly, the graph shows us that VO2 starts off higher on the orange line after these adaptations have occurred. This is due to the adaptation of the increase in tidal volume, due to the intercostal muscles allowing more air in the thoracic cavity. This therefore would mean more oxygen is consumed per breath, which would mean VO2 is higher at all stages of the graph, as per breath more oxygen is consumed. The graph also shows that these adaptations have taken place, VO2 max. After these adaptations have taken place, VO2 max is also higher, as you can see here in the graph. This specific adaptation is the overall goal of aerobic training, and as the graph shows, can be improved and increased due to this type of training. We can see throughout the whole graph the line for before has lower VO2 measurements at all points. This allows clearly to see the adaptations that have taken place and also how they affect VO2, as the lines for after show a much more successful and higher VO2, showing that these aerobic adaptations take place successfully and would therefore improve a sports performer. This, in terms of an event performer or games player, would mean they are able to aerobically better and be a better endurance athlete. This, for a marathon runner, would mean that they would perform better and would be able to complete this event in a faster time, therefore showing that these aerobic adaptations will cause improvements in their events. As well as this, if a footballer improves endurance-wise, this would mean that they can sustain a high intensity throughout the whole game, also improving them in their sport dramatically. Neuromuscular system adaptations. In terms of neuromuscular adaptations that take place as a result of prolonged aerobic training, there are many of these which will improve performance in all sporting events. For example, firstly, an adaptation that will occur due to this type of exercise would be slow. Oxidative muscle fibers will become stronger and better and more efficient in how they use oxygen. In addition to slow oxidative fibers, the more you aerobically train, the better your fast oxidative glycolytic fibers are at efficiently using oxygen as well. These adaptations would therefore mean a performer would improve, as they have much stronger and efficient muscles that they use in their events, and would therefore mean that they will improve as they can work better, needing less oxygen than before, which would also mean they are able to work for longer. In addition, another adaptation that will occur to the neuromuscular system will be an increase in the size and the amount of mitochondria, which will mean the body is able to make more energy. This is due to the fact that the aerobic energy making process, such as the Krebs cycle and electron transport chain, where most energy is made, both take place inside the mitochondria. Therefore, if you have more of these mitochondria, more energy can be made. As well as this, myoglobin stores will also increase to provide more oxygen for this to occur. Making energy aerobically requires oxygen, and therefore if the amount of oxygen is increased, the amount of potential energy that can be made will also increase. These factors would help both event and games player performers, as providing more energy will enable them to work at a higher intensity and for a longer duration, A marathon runner would need very large amounts of energy in order to complete the event. Therefore, this increase would help improve their performance. As well as this, a footballer would need a lot of energy in a game, and an increase in this would cause them to be able to play at a higher intensity throughout the whole game, meaning that they would also improve. These are adaptations that will occur to the neuromuscular system due to aerobic training.